Assalamualaikum. Hi guys. In the previous Bohr's theory, we learned that this guy stated that electrons move around nucleus in circular orbit. In other words, we can say that in Bohr's theory, the electron was thought of as orbiting the nucleus in a way the Earth orbits the Sun. This would mean that at any moment, we cannot predict the precise position, but also the precise speed of the electron. So this is not allowed in quantum mechanics. So how do you want to detect or determine the precise position and speed for an electron? That's why one guy here in 1927, Werner Heisenberg showed from quantum mechanics that it is not possible to know with unlimited accuracy both the position and momentum of a particle. This particle here is what I'm referring to, an electron. So now we are going to learn about the theory for Heisenberg's uncertainty principle. So Werner Heisenberg was a leader in physics. He won the Nobel Prize in Physics for his discovery of uncertainty principle, which states that it is very impossible to specify or to determine the exact position and momentum of a particle at the same time. So the particle here is usually we refer to the tiny piece of matter. The most usual one is an electron. So Heisenberg showed that position and momentum of an electron cannot be known simultaneously. He stated that from this expression, we have delta x is for uncertainty in measuring the position, delta p is uncertainty in measuring the momentum, which is equals to the mass times velocity, the one that I've taught before in de Broglie's postulate. And last but not least, we have h as Planck constant. Heisenberg uncertainty principle states that the product of the uncertainty in the particle's position, delta x, and the uncertainty in the momentum, delta p, this product of a particle is equal to or greater than Planck's constant divided by 4 pi. Delta mv here can be also to replace the delta p. So m is the mass and v is velocity. For objects large enough to be seen, so the mass is very large, the uncertainties delta x and delta p can be quite small, and hence we can determine their orbits. But if we take the mass of an electron, which is extremely small, the uncertainties become significant. This means that it is impossible for us to describe how the electron moves in an atom. So by applying Heisenberg's uncertainty principle to the hydrogen atom, we see that in reality, the electron does not orbit the nucleus in well-defined path like we think it is. For example, I have this Bohr's model. So Bohr's atomic model said that the electrons are going to circulate in the orbit, as in the nucleus in the middle of an atom. Actually, this model is not quite right to explain the movement of electron. So based on Heisenberg uncertainty principle, we can only determine or calculate the probability of finding an electron in a certain position at certain time. This leads to the concept of the orbital, where orbital is known as the region in space where there is high probability of finding an electron in an atom or molecule. So that is the definition for an orbital. We are going to learn more details about this orbital in the next subtopic. So I hope all of you can understand based on two findings, de Broglie's postulate and Heisenberg uncertainty principle. Both of them managed to overcome the limitation of Bohr's theory by explaining based on quantum mechanics. So that's it for this video. I'm going to see you in the next one. Bye!